Hello everyone. We'll wait for a few more minutes before we start the session. While we are waiting for others to join, if you guys have any doubts from the previous lectures or from the previous assignments that we had discussed in the previous weeks, you may raise your questions. If you want to speak during this session of this meeting, then you'll have to raise your hand using the meeting option. For the sake of convenience in conducting these sessions, your mics have been disabled. Once you raise your hands, I'll allow your mic and you can speak up and ask or discuss. All right. Before we start this session, can somebody raise their hand and just confirm if my slides are visible and am I audible, and if my slides are changing? Is it all working fine? Yes, Dr. Satish, I have allowed your mic. Can you please confirm?
You are audible, screen is visible.
And the slides are changing as well, right?
Yes, yes, yes.
Okay, thank you. Okay, hello everyone. Welcome to the weekly discussion and doubt clearing session number 5 of the NPTEL course Maintenance and Repair of Concrete Structures NOC 23-CE06, which is taken by Professor Radhakrishna G. Pillai of IIT Madras. I am Ashirvad Satpathy. I am a PMRF research scholar at IIT Delhi, and I am the officially assigned TA, teaching assistant for this NPTEL course. And what I do is I take these weekly sessions where I discuss the previous week's lectures, and we take the doubts. We discuss the doubts that you might be having regarding these lectures from the previous weeks. Also, we discuss the assignment problems that have been given to you, which you have already submitted the answers of, so that you get a better and clearer understanding of the subject. There is another assigned teaching assistant for this course. His name is Umesh. He usually takes his weekly sessions on Fridays from 7 to 9 p.m. And I take my weekly sessions on Saturdays from 6 to 8 p.m. Uh, During the course of this session, the link for this meeting or the session remains same, so which is generally mailed to you by NPTEL. Uh, Apart from this, I record these weekly sessions and I upload it on YouTube. I have already pasted the link of the YouTube link of the previous session in the meeting chat. You can check it out if you want. I also share the lecture slides that I prepare for these sessions, and along with the annotations that we use during the meeting. So I also upload those lecture slides into OneDrive. I've also shared the link of that OneDrive folder in the meeting chat. You can check it out. All right. In today's session, we'll be discussing the week 4 assignment 4 questions. There are around 8 questions that were given to you. And this week's lecture was more or less regarding in the previous week, we had discussed the various deterioration mechanism of concrete. Previously, we had discussed about the deterioration of steel in the concrete. Then we discussed about concrete, like several attacks that the chemical attacks, like sulfate attack or um, let's say alkali silica reaction. That this kind of the chemical reactions that take place within the concrete. In this week, the week 4 lecture, we discussed regarding the another type of damage rather than deterioration mechanism, a damage mechanism caused by fire or elevated temperatures, and also the abrasion of concrete due to several processes such as erosion or cavitation and whatever it is. Uh, Apart from this, we also looked at the various lab testing procedures, and how we can evaluate the quality and the various deterioration that has taken place within the concrete structures by visually or using certain equipment, simple and sophisticated equipment, and we can carry out a evaluation of the quality and the strength and the durability of the concrete on site as well as in laboratories. All right. And so we'll be taking this the assignments are regarding the assignment questions were mostly regarding these week 4 lectures, and at the end of the session we'll be taking some doubts which you might be having regarding these mechanisms that were taught in the week 4 lectures, or also if you have any doubts from the previous lectures, we can take those doubts as well. So the first question of this week 4 assignment was, what mechanisms might happen in a reinforced concrete system when exposed to elevated temperatures, say greater than 700 degrees Celsius during a fire attack? And the options were the tensile capacity of the reinforcing steel decreases, the ductility of the concrete increases, the thermal conductivity of concrete can decrease, the compressive strength of concrete increases, the hardened cement converts to quicklime, the pore pressure increases due to the condensation of the pore water to steam. Can somebody answer to this question? And let's keep this session interactive. So we'll be discussing all these questions, and you guys can give your inputs, you guys can give your guesses, and we'll be discussing the mechanism that take place, and we'll be discussing the answers as well. Please raise your hands if you want to answer to this question. Okay, yes, Dr. Satish, you can unmute yourself and speak.
Yeah. You see, first option given is the tensile capacity of the reinforcing steel decreases. Yes, definitely. At higher temperatures, it can come down to a very low value of the order of 10-15%, as happened in Vigyan Bhavan fire we had in 90s.
Okay.
It had come down. Ductility of concrete increases. No, no question. Thermal conductivity of concrete can decrease. Yes.
Okay.
It was discussed in the lecture. The compressive strength of concrete increases. I don't think that is the case. Then the hardened cement converts to quicklime. Yes, that has been observed. And the pore pressure increases due to condensation of pore water. That is also correct. So 4 answers are correct. The other 2 are incorrect.
Okay. Thank you. Thank you, Dr. Satish. Yes, these 4 answers are actually correct. So we'll be discussing all the statements one by one. The first statement was the tensile capacity of reinforcing steel decreases. This is true because as we go on increasing the temperature, it causes warping and deformation and even buckling of the steel reinforcement, and also it affects the strength carrying capacity of the reinforcing steel, and eventually the tensile capacity of the reinforcing steel decreases. So this is a true statement. The ductility of concrete increases. This is wrong because already concrete is a brittle material, and as we go on increasing the temperature around say 700 to 800 degrees Celsius, in fact the fourth option, the fifth option is correct. The hardened cement converts to quicklime, and so the concrete becomes powdery and brittle, and even more brittle in nature. So the ductility of the concrete won't increase. So this is a wrong statement. The thermal conductivity of the concrete can decrease. This is true, yes. With increase in with exposure to elevated temperatures, the thermal conductivity of the concrete will decrease. The compressive strength of the concrete increases. This is again wrong. But initially, at around let's say at around 100 to 200 degrees Celsius, the concrete strength might increase, and this essentially happens because the pore water is lost. The pore water that might be trapped within the concrete, that gets lost, and that causes a stiffening of the concrete microstructure. And we have to keep in mind that concrete is, as a material itself, is innately fire resistant. So concrete has a very good fire resistance compared to other construction materials that are used in the industry. Concrete has a very good fire resistance. So at around 100 to 200 degrees Celsius, only the concrete isn't affected. The strength or the durability, or I mean the functioning of the concrete microstructure isn't affected much. Only the water trapped within the voids of the concrete might get evaporated, and that will cause a stiffening of the concrete, which might result in a certain level of increase in the compressive strength. But when we are going beyond that temperature, beyond 250 degrees Celsius, concrete loses its fire resistance property and it starts to deteriorate. So when we're talking about this high a temperature, let's say 700 degrees Celsius, the compressive strength of concrete will not increase. Rather, it would have decreased significantly. So this is a wrong statement. The hardened cement converts to quicklime. Yes, this is again true because when you're imparting, as we have discussed many a times in the previous sessions as well, when we are uh, clinkerizing, I mean, the process of clinkerization essentially is imparting energy to these materials, these clayey materials, these lime in raw form, which um, converts these raw materials into clinker phases like alite, belite, and aluminate and ferrite phases. So whenever we are imparting higher temperature to these materials, these get converted again when this high temp another I mean you're exposing it to a fire or a elevated temperature system. These systems are already in a high energy level, and they'll want to come down to their previous energy states, which is basically the raw material. So at higher temperatures, the hardened cement converts to quicklime. This is a true statement. And the pore pressure increases due to the condensation of pore water to steam. That is again true. And this has been also might be discussed in the lecture as well. So whenever there is an exposure of the concrete to elevated temperatures, the pore water that is present in the concrete voids, that vaporizes, that gets converted to steam. And since the water vapor has a high amount of kinetic energy, the molecules have very high kinetic energy, they undergo Brownian motion, and due to those effects, the vapor wants to escape out of the pores of the concrete. And if the concrete doesn't have a sufficient pore connectivity, or a pathway for the pore steam, the steam in the pores to escape out of the concrete surface, then that will cause expansive stresses within the concrete, and this might lead to explosive spalling. So there is one progressive spalling that we have discussed in previous lectures as well, which happens in the case of corrosion. So the corrosion products get deposited over the steel reinforcement, and with time eventually with the further deposition of these corrosion products, this that they have a higher volume, and that causes expansive stresses within the concrete, and that creates cracking, and this cracking further improves or further broadens, and this might cause spalling, and that is progressive spalling because it takes time. So one is a progressive spalling. I'll write over here progressive spalling, and this takes place in corrosion, or let's say ASR, all the microstructural processes that cause expansive stresses. They undergo progressive spalling, but explosive spalling takes place in the case of fire attack, because there is a sudden vaporization of this pore water, and that creates a lot of stress within the concrete, and the pore water wants to escape out of it, and if it doesn't get a easy path available for it to escape out of the concrete, that will cause explosive spalling of the concrete structures. So these four statements are true. All right, moving on to the second question: which of the following concrete mix designs will have the highest abrasion resistance? The notes is W by B means water to binder ratio, A by B means aggregate to binder ratio, and all of these mixes listed out are M30 mix. So an M30 mix with a water to binder ratio of 0.6, aggregate to binder ratio of 5, gap graded, quasite based aggregates, and accelerating admixtures versus and the fifth was water curing. So which of these mixed design parameters is going to give you the highest abrasion resistance of the concrete that is produced out of this materials? The second option was a lower water to cement ratio, 0.5. Aggregate to binder ratio is again the same, 5. It is again gap graded, quartzite-based aggregates, and retarding admixtures. And air curing again. This was water curing, but this is air curing. The third option is water to binder ratio of again 0.5. Aggregate to binder ratio increases. Well graded aggregates, limestone based aggregates, air entraining admixtures, uh, versus, and the final was water curing again, the curing process. The fourth was water to binder ratio of 0.5, aggregate to binder 0.5, uniformly graded aggregates, shirt beds aggregates. So this is a different type of aggregate, shirt weights aggregates, and anti-bleed mixtures. Air curing is done for this concrete. And the last option was water to binder ratio of 0.5, aggregate to binder ratio of 6, well graded. And compared to the third option, this has shirt based aggregates instead of the limestone aggregates, and again has anti-bleed mixtures and water curing. So which of these options will give you the best abrasion resistance in the concrete produced? Can somebody answer? I would encourage for others to answer. Arka, Manisha, if you guys want to take guesses. Yes, Orca has raised his hand. I've allowed your mic, Orca. You can unmute yourself and speak.
Sir, the correct option would be option number 4. The water binder ratio would be 0.5, aggregate binder would be 6, it would be well graded and chert based. Actually, chert is more harder than limestone, so it will be preferred.
Which option
For
are you talking about? The third?
fourth, sorry, the last option, the last option.
Okay. Yeah, the last option. Okay. Yeah, so aggregate to binder ratio, a higher aggregate to binder ratio, a lower water to binder ratio,
Yes,
and
sir.
shirt based aggregates, right?
Chert based.
Yeah.
Yes, sir.
And yeah, the anti-bleed mixtures and water
And
curing.
water curing.
Okay, thank you. And
Water
could
curing.
you shed some light upon all these different types of mixed design parameters and how they affect the abrasion resistance? Like, why do you want to choose a water to binder ratio of, I mean, lower water to binder ratio than zero point 0.6? Why not a zero point 0.6 and why a zero point 0.5? If you given the option, why would you choose 0.5 water to binder ratio for higher abrasion
Sir,
resistance?
actually, the more amount of binder will give hardness to the concrete.
Okay, okay, good. And the second thing, higher aggregate to binder ratio. Why would you choose that?
Aggregate to binder ratio, the amount of aggregate should be more.
Yes. Why is that?
Then it will give the composite strength to the concrete.
Okay. Composite strength as in?
That means it will make the concrete more harder.
Okay, okay, okay. And well graded aggregates and not uniformly or gap graded aggregates. Why would you choose that?
Sir, I don't have a right idea of that.
Okay. Let's move on to shirt based aggregates. You have already told that these are a little
Yeah.
harder material. Anti-bleed admixtures, what do they do? Do you have any idea?
Yeah, they will prevent bleeding of water from inside
Right.
of the
Okay.
concrete mix.
Right. And water curing versus air curing. Why? Which one did you choose and why? I mean, you chose water curing.
The water curing will be helping in the hydration reaction of cement.
Okay. Yeah. Okay. Thank you so much. Thank you so much,
Thank you,
Orca.
sir.
Yeah. Yes. So I have taken these graphs, these curves that is also given in the lecture as well by Professor Pillai. So these are the effect of compressive strength, the effect of water to cement ratio, and the effect of different types of aggregates on the abrasion resistance of the concrete. And you can see that so when we are moving from a higher compressive strength to a lower compressive strength, the loss of volume increases. The loss of volume as it the more amount of concrete gets abraded, it loses the depth, the concrete depth, the amount of concrete gets abraded from the surface of the concrete elements. So as we are moving down in this curve, the loss of volume, the volume loss increases. So it is good to have a higher compressive strength, and a higher compressive strength will give you a higher abrasion resistance. So whenever we're talking about water to binder ratio, having a lower water to binder ratio will give you a higher compressive strength, and therefore will also give you a better abrasion resistance. Now coming to the effect of water to cement ratio directly, again as we have mentioned in the last case, we can see that in this view graph, as we are going on increasing the water to binder ratio, we see that the abrasion erosion loss, and this on the y-axis it is the loss and not the abrasion resistance. So the percentage of the amount, percentage by mass, or the weight of the specimen that is getting, we are losing from due to the abrasion of the concrete, that goes on increasing with the increase in the water to cement ratio. So again, water to cement ratio, increasing the water to cement ratio will decrease the abrasion resistance and increase the loss of concrete due to abrasion. Moving on to the third view graph, you can see that these are the different types of aggregate materials, and we can see that the limestone based aggregates have the highest amount of loss of concrete due to abrasion, while the chert based aggregates have the best resistance to abrasion attack on concrete. So using chert based aggregates is better than limestone. So this is the decreasing order increasing abrasion resistance. So as we are moving from limestone to chert based aggregates, the abrasion resistance increases. So and finally, I want to mention about the aggregate to binder, having a higher aggregate to binder ratio. Aggregates are the most compact material that we use in concrete. They are naturally produced, and therefore they have the most compact microstructure. In fact, in most of the failures, most of the material failures, the aggregates are not broken. It is the interface between the aggregates and the cement or the mortar paste, the cement paste or the mortar, that gives a path for the breaking of the element, the concrete element. So the aggregates are the most compact and have the highest strength in the concrete, and therefore having a higher amount of aggregate not only decreases the cost of your structures, but also it will give you a better abrasion as well as abrasion resistance to the concrete. And anti-bleed admixtures are basically used whenever you're using a water to binder ratio as high as 0.5. There is a sufficient chance, because in case you're using normal Portland-based cements and not any blended cements, there's a high chance of bleeding and segregation in the case of Portland ordinary Portland cement concrete at this water to cement ratio of 0.5. And whenever you're using these, and so there is a need for using these anti-bleed admixtures, so that it will restrict the bleeding or the rising of the water, the mixing water from the concrete to the surface, and that will prevent the formation of a latent layer. You might have heard of this, a latent layer. So if this bleeding water is present over the concrete surface, and after the concrete sets, this bleed water, it might evaporate, but if some of it remains over there, that's a very thin layer of cement or mortar, cement paste or mortar that lies over the concrete after it has set, and this is known as the latent layer. This latent layer has a very low compressive strength. It has very less abrasion resistance. It is very porous, so it will allow the transport of the water and as well as the ions. So we should avoid the formation of a latent layer, and anti-bleed admixture avoids the formation of a latent layer or bleeding. caused by the bleeding. And again, as we know that water curing will ensure that you allow the concrete or allow the cement to undergo the highest possible degree of hydration, and so that we ensure that almost all, not if not all, maximum portion of the cement gets hydrated, and that will allow to uh, uh, for I mean that will allow for the concrete to gain the maximum possible compressive strength that is possible from this mixed design. So this was the correct answer, the last option. All right. Moving on to the third question. Location of delamination of carbon fiber Delamination of a carbon fiber reinforced polymer wrapping in a bridge deck can be determined by which of these options, and you have to choose the most suitable method. The most suitable method and which will give you a reliable result of detecting the delamination of these CFRP wrapping around the bridge deck. So the options were hammer sounding, chain drag sounding, infrared thermography, ground penetrating radar. Which of these options are correct? Can somebody answer to this question? I see somebody else has joined the meeting, Mohini. If you guys want to answer to this the question, please raise your hands and I'll allow your mic. All right. Dr. Satish, you have raised your hand. You can go ahead and
I would
answer
like
if
to
you
reply to this question. It
Yes.
was told in the lecture that for such a situation, infrared thermography gives us idea about the delamination. Hammer sounding is relating to surface characteristics. Chain drag is also similar. And ground penetrating radar gives more about the interior. Regarding delamination, probably infrared thermography gives overall picture relating to delamination.
Right. Right. Thank you. Thank you, Dr. Satish. Yes. So this is actually the correct answer. So even if hammer sounding, chain drag sounding, these methods can also give you a certain idea about the delamination, but these are not very reliable methods. So these are very old and not so reliable methods, and especially these are used for normal concrete, where the delamination occurs, as we have discussed, due to the formation of a soft a thin layer of cement paste or mortar above the concrete. So hammer sounding is like using a in fact, hammer sounding is a sophisticated equipment, but this is again used for the normal concrete specimen. So wherein what you do is that um, uh, you you use this hammer and you hammer over the concrete surface at different locations, and you see what is the quality of concrete, if there is a delamination, possible delamination or not, and based on that you can draw a contour plot, or you can draw you can find out the possible locations where there might be delamination. However, the use of this equipment is also dependent on the operator, and it is not a foolproof instrument to use, because it has a dependence on the operator, and it is a very subjective assessment of the quality of the structure. Coming to chain drag sounding, again, as I mentioned, it is a very old method. That what we do is we generally run these frames which have chains over the concrete surface, and based on the sound that is coming out of the concrete, we decide if the concrete has a hollow portion or it is filled. And again, this is a subjective assessment. Subjective assessment can vary from operator to right. And infrared thermography is the best possible option for finding or locating the portions of concrete or bridge deck which might have delamination of the CFRP wrapping. And this you basically uses a um, infrared rays, and based on the temperature that is being produced on these surfaces of the concrete, it will give you a contour plot, or it will directly give you the regions which have delamination compared to those regions which do not have a delamination over the bridge deck. So this is the best possible method to do this check of delamination of CFRP wrapping around the bridge deck. And again, ground penetrating radar, as already Dr. Satish has mentioned, this is generally used. I mean, as the name suggests itself, it is penetrated uh, over the ground, inside the ground, and it is not something to decide about the wrapping that is done over the surface of the bridge deck. So it essentially gives us an idea about the inner structure of the concrete rather than the CFRP wrapping around the bridge deck. So infrared thermography is the best possible method that will give us an idea about the delamination of this CFRP wrapping. All right. Moving on to the fourth question, a commercial reinforced concrete building is located near a flyover in a tropical city. No paint or coating layers have been applied on the concrete surfaces. Where do you suspect the carbonation rate to be higher? The options were exterior columns exposed to sunlight, interior columns, exterior beams exposed to sunlight, underside of roofs, upper side of the sunshades. It must be highlighted that no paint or coating layer have been provided over the concrete surfaces. Which of these options are correct and why? Can somebody answer to this question? Orko, have you raised your hand?
Yes, sir.
Yeah, you can
Actually,
go ahead.
the correct options would be option number 2 and option number 4. That is interior columns and the underside of roofs, which are away from sunlight and moisture. No,
Okay,
moisture would be present. That's why the carbonation reaction would take place.
right. Okay. Yeah. So you what you mean to say is that these two options would have moisture present, right?
Yeah,
Moisture present, and other options we won't will not have the moisture present due to the presence of sunlight, and of course this
yeah. Due
upper
to
side of
heat.
the sunshades. Yeah. And why do you think that the presence of moisture would increase the carbonation rate?
It will help in absorbing the carbon dioxide, the carbon molecules.
Okay. Okay, thank you, Orca. Yes, so these are the two correct options, the interior columns and the underside of the roofs. So the first of all, coming to this statement, no painting or coating layers are provided over the concrete surfaces, because whenever you're comparing the rate of carbonation of concrete, and if you compare it from a concrete that is the surface of which is not coated with that of a concrete which has a coated surface, you'll find a severe difference between both of these concretes, because it will depend on the type of coating that you're applying over the concrete surface. Let's say you're applying a waterproofing compound over the concrete surface, that will not allow the ingress of moisture inside the concrete, and that will affect the carbonation reaction. Let's say you're applying some other kind of a chemical compound, and depending on the composition of the chemical compound, that will also interfere with the carbonation rate. So whenever you're comparing two different types of concrete specimens or concrete elements, you need to ensure that both of them have uh, the same exposure conditions and the same applications, that application of various compounds that you might have provided over the concrete surfaces. Secondly, um, exposure of columns to sunlight or exposure of surfaces, concrete surfaces to sunlight will essentially increase the temperature, and that will let the moisture inside the concrete to evaporate. We know that increase in temperature, so I'll write over here, increase in temperature increases the carbonation rate. That's true. If you provide, let's say you're doing this test in a laboratory and you can compare it yourself, if you have an access to a laboratory, and if you are carrying out this carbonation tests over two specimens of concrete, one is exposed to a room temperature and one is exposed to a high temperature, then you'll see that the carbonation rate of the concrete that is exposed to a high temperature will be high, provided sufficient moisture is available. And this is the essential condition for carbonation to occur. If if there is sufficient moisture available, then exposure to sunlight will increase the temperature and it will further increase the carbonation rate. But whenever you're not providing any moisture from outside, and which is the case in the normal structures, like the structures that are directly exposed to sunlight, nobody is going to cure those structures, let's say the bridge decks or the outer surfaces of the buildings. Even nobody is curing that, nobody is providing water externally to those surfaces, and therefore exposure to sunlight will lead to evaporation of the water from the pore, and therefore it will decrease the relative humidity within the concrete, and that in turn will affect the carbonation process. And how does relative humidity affect the carbonation process? We have discussed this in the previous sessions as well. So for carbonation to occur, there has to be two important criteria that has to be fulfilled for carbonation to occur inside the concrete. One is the availability of carbon dioxide, which is everywhere available. I mean, it isn't present in the atmosphere, and so carbon dioxide can get inside, right? However, if the concrete surfaces are saturated, then the solubility of carbon dioxide is low, right? Sorry, just give me a moment. So the solubility of carbon dioxide in water is low, and therefore, if the concrete surfaces are saturated all the time, the carbon dioxide cannot enter inside the concrete. However, let's say once the concrete surfaces are dry and the degree of saturation is low, now carbon dioxide can enter inside. But for the carbon dioxide to react with the calcium ions inside the concrete, which is essentially which will essentially lead to the formation of calcium carbonate, which is the carbonation product. For that to happen, this carbon dioxide needs to have sufficient moisture inside the concrete again, so that it will form this carbonic acid that will react with the reserve alkalinity of the concrete, and that will lead to the formation of um, calcium carbonate, which is essentially the carbonation, which will essentially is known as the carbonation of concrete. So once the carbon dioxide has entered the concrete, so sufficient relative humidity, at sufficient relative humidity, carbonic acid is formed, plus CaOH whole twice. It reacts with the portlandite and leads to the formation of calcium carbonate or the carbonation of the concrete occurs. So we need to have the carbon dioxide inside the getting inside the concrete surface. Also, we need to have sufficient moisture, and we had seen in the previous lectures as well. So the if the carbonation rate is compared with the relative humidity inside the structure, this, let's say this is the relative humidity percentage and this is the carbonation rate, and we have seen that this occurs like this at a relative humidity of 60 to 80%. So at a relative humidity of 60 to 80%, the maximum, the rate of carbonation is maximum, because below this, the pore is dry, the pores of the concrete are dry, and therefore the carbonic acid cannot form, and therefore the carbonation cannot occur. And above this relative humidity, um, the the solubility of carbon dioxide in water is low, and therefore carbon dioxide cannot enter inside the pores. So it is at this relative humidity between 60 to 80% that the maximum carbonation can occur. The rate of carbonation is the highest. So we know that availability of sufficient moisture to the concrete surfaces is a must criteria for carbonation to occur. Of course, not supersaturation, not drying of the concrete surfaces. The availability of the optimum amount of moisture accelerates the carbonation process, and therefore when the interior sites or the sites that are under the shade, that will have lesser drying as compared to the surfaces that have higher drying due to the exposure to the sunlight, and therefore in these conditions there will be sufficient moisture available, and that will increase the carbonation rate. So these two are the correct answers. All right. Moving ahead to the fifth question. The presence of irregular and pitted damage on the concrete surface in the spillway of a dam structure indicates abrasion-induced damage. Is it a true or a false structure? I'll highlight this: the spillway of a dam structure and a pitted damage. Is it a true or a false statement? Can somebody answer to this question? Please raise your hands. Dharmendra, you want to answer to this question? Or Orca, Manisha? Do you guys want to answer? Yes, Orca, go ahead.
Sir, actually, the erosion is occurring due to water, so there is nothing solid particle which would be abrading the surface of the spillway. So
Okay.
it is not true. It will be false.
Okay. And so if there is a, so what kind of corrosion or the damage, the irregular and pitted damage that is occurring in a spillway, what kind of a damage would it be? Like, it is induced due to what process? Can you
Actually,
generally
it
what?
is induced due to frictional force, due to the and the viscous force of water.
Okay. 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 Thank you, Arko. Yes. Anybody? Yes, Dr. Satish, you have also raised your hand. If you want to answer, you can.
Yes, yes. It could be due to cavitation because a lot
Yes.
of air bubbles will be there. Because of cavitation phenomena, there will be damage to the surface.
Yes. Right. Thank you, Dr. Satish. Thank you, Orca, for answering the questions. Yes, this is a false statement actually. The irregular, I mean, see, in
Sir,
the
can you
case of,
please highlight the cavitation procedure?
yeah, I'll tell you, I'm just describing that. So, in both the cases of abrasion, let's say in abrasion as well, abrasion, so I'm just remove this. Comparing both the process, the abrasion as well as the cavitation, in both these cases, there is a localized damage. Here also there is a localized or pitted damage, both of these cases. And you can see, but essentially the difference between abrasion and cavitation is that abrasion is generally occurring, as Orca has already mentioned. This occurs mostly due to uh, the the impact bit of the various debris or the I mean harder particles that are moving over the concrete surface. Let's say there are steel wheels over a concrete deck, concrete bridge deck, that will cause abrasion. Or let's say there is a so, there is a concrete pier and there are certain pebbles at the base of the soil, and there's the water moving, and these pebbles are maybe getting hit over the concrete surface, and that might cause abrasion of the concrete surface. So if you, let's say this is a bridge deck, there's a bridge deck and this is the base. So this is the base, and you might see that there are certain pebbles or any harder materials lying around, and they might collide with the surface of the concrete, and that might cause the abrasion at these base points. And this might, you might have seen this in the lecture as well. So there is abrasion and loss of concrete from the bottom. Also, if a steel wheel is rolling over steel wheel or anything harder, any harder material, or there is impact between these wheels over the deck, concrete deck, that might cause abrasion at certain points. So this is more or less due to the hitting of the harder solid particles. So hitting of harder solid particles. But in the case of cavitation, what happens is this happens due to the irregularity in the shape of the hydraulic structure. So this cavitation process essentially happens in hydraulic or water retaining, not water retaining structures, or but rather the structures that in which the water flows through. Let's say some crosswalks or anything, any kind of water, or canal lining as well. Any kind of a structure in which there is movement of water or hydraulic structures. This might happen, and this happens due to the irregularity in the surface of the concrete around in which the water is flowing. Let's say this is a concrete surface. This is a concrete surface, and there is a sudden change in curvature at this point, and there's flow of water through this concrete over this concrete surface. And at this point, when the water hits this point, there is formation of these bubbles, air bubbles. So due to the impact of water, due to the movement of water with high velocity and the impact of water at certain curvature of the concrete surface, So these air bubbles are formed due to this impact of water, and within this water, whenever these large air bubbles are formed and they coalesce or they stick together, they form higher flocks or grow larger in size, and once they grow larger in size, they implode. So implosion of these air bubbles will create the water in between. Let's say this has also been probably shown in the lecture as well. Let's say this is a bubble, and there are two bubbles, and they to form a larger bubble. Coalesce to form a larger bubble, and this bubble implodes. So there is implosion of the bubble, and this implosion will result in the water gushing into through this the gap between these two imploded bubbles, and the water will gush in at a very high velocity, and that will hit the concrete structure. And at this point, due to the high velocity of the water, the concrete starts to erode. Starts to lose its mass, and this is the kind of pitting that might occur at these sudden curvatures within the concrete. So if this concrete was previously looking like this, due to the movement of the water and the cavitation process, the concrete will lose its mass at this point and start to lose its. I mean, a pitting kind of a damage will occur at this point. So, due to the irregularity in the shape of these hydraulic structures, this cavitation process occurs. The cavitation is this process, the implosion of these bubbles that are formed due to the higher velocity of the water, and this cavitation will impart a large amount of stress on the concrete at that particular location, and that will create the cavitation induced damage. I hope that's clear.
I want to add something.
Yes, Dr. Satish.
You see, the top expert in cavitation had been one Indian, Professor N.S. Govinda Rao,
Okay.
who became a professor of director of Indian Institute of Science, Bangalore, had been head of Department of Civil Engineering. With a B to his credit, he produced 16 top PhDs in the country.
Okay.
Including geotech engineering. He was only B.
Okay.
He sat in the same, he became director also in 50s, and by chance he interviewed me in engineering services 76. He came in wheelchair, 80 years plus at that point of time. I'm just adding some personal information about the authority. He was a top authority on cavitation.
Okay. Thank you, Dr. Satish. Yes. So this is essentially the cavitation process, and it is a very harmful phenomena. And you might have also seen, to avoid this, the occurring of cavitation. So instead of providing very large slope, instead of providing a large slope, what you can do is to reduce the velocity of the water. You can provide these steps so that the moment of the water that is gushing through over this concrete surfaces, that momentum is reduced, and therefore the cavitation is decreased. Also, in the design, it is generally avoided to provide certain very sharp bends or very sharp curvatures within the concrete surface, over the concrete surfaces, so that the cavitation induced damage will be less. So this is what is the difference between abrasion and cavitation. So in case of water, unless there is a debris flowing over the water, that might be affecting, that might be hitting over the concrete surface. This damage, this irregular and pitted damage, is mostly due to cavitation. But if there is a debris flowing along with the water, then that might be due to both abrasion as well as cavitation. All right. Okay. Orko, you had asked this about cavitation. I guess this is a little bit clear
Yes,
now.
sir. Yes, sir. My doubt is clear, but If we introduce steps for reducing the speed of flow of water, then also the at the junction of the steps, the
Yeah, I know.
cavitation can occur.
Yes, but yeah, but there is not enough surface. I mean, there is not enough time for the water to stay at, I mean, that location and for the formation of these bubbles and everything. So these steps are very. I mean, the height of these steps could be very small. So the the water, instead of hitting over each step, it can directly move on like this, and
Okay, the above
that will
layers
not,
can move.
yeah, that will
Yeah.
not hit over the surface, and there will not be sufficient time present for the air bubbles to be formed and implosion of the air bubbles to cause the cavitation induced damage.
Yes, sir. Clear. Thank you, sir.
Okay, all right. All right, moving on to the sixth question. It was severe cracking and concrete delamination have been observed on a residential building located near the coast in Chennai. All right. Choose all the three best condition assessment parameters from the given options that you would recommend to identify the root cause of the problem. So there is severe cracking and concrete delamination, and it is nearby to the coast. The residential building is nearby to the coast. Which of these options would be the best condition assessment parameters? Impact echo from the concrete, rebound number of the concrete, chloride profile, carbonation depth, compressive strength, chloride diffusion coefficient, and flexural strength. Which of these would you consider to assess the quality or the root cause of this severe cracking and concrete lamination? Can somebody answer? Yes, Orca, you can go ahead.
Yes, sir. Sir, actually, since it's mentioned that the building is located near the coast, so we can um, assume that corrosion induced due to chlorine diffusion and sulfates can be the main cause. And if there is moisture also, since it's placed near the seashore,
Mm-hmm.
so carbonation can be also the cause.
Mm-hmm.
So so for identifying the root cause, we can go with chloride profile, carbonation depth, and chlorine diffusion coefficient.
Okay. Thank you so much. Very nicely explained, Orca. And would you like to also share something about these tests? Why would you not consider the impact echo or the rebound hammer or these compressive or the strength tests? Why would they not yield the best solution for finding or
The,
determining the cause of the problem?
the other options are also very general that they help in identifying the delamination. Um, like we can understand the surface strength of concrete by the rebound hammer number. But
Uh-huh.
since they have mentioned the conditions like coast side and delamination, so the I think chlorination induced corrosion may be the main cause for that.
Right, right. Okay, great. Thank you so much, Orca.
Thank you,
Yes.
sir.
So the there is severe cracking and concrete delamination in a residential building which is located near the coast. Now whenever you see that is located near the coast, you have to first identify. So as we have also discussed in the lecture as well, Professor Pillai has also discussed that you have to do a visual assessment of the structure and the condition of the structure. So let's say there is cracking in the concrete, and if you see that there is a certain pattern to the cracking, let's say we have also discussed this in the previous lectures, in the previous sessions, um, the corrosion induced cracks occur. Let's say this is a concrete element, concrete beam, and there is reinforcement inside the beam, then the corrosion induced cracks will occur along the longitudinal reinforcement, right? Because there is deposition of the corrosion products and around the steel rebars, and therefore the corrosion induced cracks will occur along the concrete reinforcement. But let's say there's these cracks are formed due to the structural damage of the concrete. Let's say it's due to the flexural strength being lesser than what is required in the structure. So if this is we've also discussed this in the previous lecture. If this is a concrete beam that is getting bent, if this is a concrete beam that getting bent due to certain loads over it, then the flexural cracks will occur at the bottommost portion and perpendicular to the reinforcement, because there is tensile stress induced like this at the bottommost fiber, and therefore there will be the flexural cracks will occur perpendicular to the longitudinal reinforcement. So these are certain the visual assessment of the condition of the structure or the type of cracking that is occurring within the structure, that will give you an idea of which of the tests do you want to take. Go ahead with for a start. Of course, carbonation, compressive strength tests or flexural strength test, you can do that. Um, you can do that afterwards. But let's say, since it is already mentioned that it's near the coast, and in order to do a compressive strength test, of course, you need to take out a core, take out a concrete core. And this is an NDT test. This is an NDT test. So it's a very small size of a core that is being taken out of the concrete structure, and again it is filled up so that the concrete inside doesn't get deteriorated. But what if we want to carry out a flexural strength at the beginning, and there this will be a semi-destructive kind of a test, or sometimes even destructive kind of a test, and therefore you will have to take a larger size of a specimen from the concrete elements, and that might even if the deterioration of the concrete structure is going due to the corrosion process. Taking out a specimen from the concrete element will further increase the rate of corrosion. And since we know that this building is located near the coast, so first of all we'll go ahead with the chloride and the carbonation and the chloride profile, carbonation and the carbonation depth, and the chloride diffusion coefficient. Now, see, as already Orca has mentioned, since it is nearby the coast, so there will be enough chloride ions or enough chloride ions in the air, so that might uh, get deposited over the surface, and that might get transported inside the concrete. If it is in contact with water, then of course there is a free path available for the chloride ions to penetrate to the concrete surfaces. Again, regarding carbonation, since it is nearby the coast, there is sufficient, of course it is not supersaturated, but there is sufficient amount of moisture available for the carbonation to occur, so that will also accelerate the carbonation process, and hence these two processes can take place and result in the corrosion of the steel reinforcement, which might create this severe cracking and delamination or the spalling of the concrete surfaces. So the best way is to go ahead with chloride profile, carbonation depth, and chloride diffusion coefficient at first. Let's say we are not getting any indication that these tests, from this test, let's say the chloride profile is very low. Chloride profile is basically, so you take out a specimen and you break it apart, and you see you spray silver nitrate solution over it, and so the silver nitrate reacts with the chlorides and forms silver chloride, which is white in color, and you'll see this chloride front over the concrete specimen, and to which depth, let's say this is the broken concrete specimen, and this is the depth of the chloride front. So this will give you an idea of the chloride profile, how much till how much depth of the concrete the chloride has ingressed. So chloride front, this is known as the chloride front, done by this silver nitrate solution test. Silver nitrate test. Chloride diffusion coefficient, you can do it using RCPT or RCMT tests. as mentioned in the lecture as well. And carbonation depth is again, it's a similar to that of the chloride front test, only instead of silver nitrate, use phenolphthalein. You break the specimen apart, you spray phenolphthalein over the concrete surface, and we know that phenolphthalein is pink in color at a pH higher than 9.2. So if the pH has dropped below 9.2, which is the case generally in carbonation, so that will give us a carbonation front, or the carbonation depth of the, will be able to find out the carbonation depth of the structure. So this is for carbonation depth. So these three will give an idea about the deterioration of concrete due to corrosion or carbonation, caused by carbonation or chloride ingress. Let's say these three results are not giving us sufficient indication that this has occurred due to corrosion. We can go ahead with the compression test, strength test, or the flexural strength test. Impact echo or the using of rebound number of the concrete are good non-destructive tests, but these tests should not be taken. These tests should not taken as quantitative. Not for quantitative analysis. So these tests are not for quantitative analysis. They only give us a relative understanding of the relative compressive strength, or I mean not the compressive strength, the relative quality of between the different elements that might be present inside the structure. So the rebound hammer doesn't give us the compressive strength of the concrete. You should keep that in mind. It only gives us the quality of the concrete. It only gives us an idea about the quality of the concrete based on the surface hardness of the concrete, and not the compressive strength. Yes, of course, several charts are available in which the rebound number has been correlated with the compressive strength of the concrete. But again, as I mentioned, these are not quantitative analysis, and they should be taken as what is obtained, instead of correlating with the compressive strength or the durability parameters, because they won't give very reliable results in all conditions. So these are not the best tests to go with. The best test to identify the root cause of this kind of a situation is chloride profile, carbonation depth, and the chloride diffusion coefficient. All right.
I have something to add.
Yes, Dr. Satish.
There is one ammonium chloride plant in Manli, North Madras.
Okay.
And IIT Madras was interested with rehabilitation of that plant. I was doctoral student at IIT Madras at that point of time. Surprisingly, I noted that this phenolphthalein solution worked even in case of chloride attack. We could assess the depth of chloride diffusion with this phenolphthalein test. It is meant for carbonation only.
Yes. Hello?
Attack.
Yes. Okay.
I reported that in one of my papers. That was a surprise for us. And normally, literature report that it works even in case of chloride attack, phenolphthalein.
Okay. And Dr. Satish, how far is it? I mean, I'm guessing that it was nearby the coast. So, and how old was the structure?
Coastal area. It was not very old, just 5 to 10 years old only.
Okay.
They wanted it to rehabilitate for just 5 years. We provided coal tar epoxy, etc. We had to redo some members, and after many years, I inquired that we found that it was still okay.
Okay.
Aesthetics was not the problem. It was in the interior only.
Okay.
It was purchased from Kothari by SPIC. SPIC is a prominent company. So I was surprised to see that phenolphthalein was working even in case of ammonium chloride attack to concrete.
Okay. Oh, nice. Okay. Yeah. Do you also think that this could have been a combined effect of chloride as well as carbonation? Because
yes, it could. It could have.
Yeah. Because see, both of these chemical processes can take place at once simultaneously.
Together.
Yeah. right?
Yes, quite possible, quite
Yeah.
possible.
So that's why I asked about the age of the structure. You mentioned that it is only 5 to 10 years old. So carbonation is a very long process to take place, and I mean,
It's a slow
generally at
process.
this,
Yes,
yeah, at this age, it is not likely that carbonation will occur. But who knows? I mean, if the
yes,
yeah, the exposure conditions are conducive enough for carbonation to occur, then it could be a possible combination of both the processes, the chloride ingress as well as carbonation. Okay,
yes.
thank you, Dr. Satish, for highlighting these on-site problems that you have experienced throughout your career, so that we also get to learn from these anecdotes. Okay, yeah. So the answer to this question, yeah, as we have already discussed, these three are the answers. Moving on to the seventh question. The severity of corrosion rate of the embedded reinforcement can be qualitatively assessed from the dash, and the options are surface resistivity of the concrete, rebound number of concrete, pulse velocity through concrete, impact echo from concrete. The severity of corrosion rate. And this is a very easy question. Can somebody answer to this question? Yes, Dr. Satish, go ahead.
Since other participants did not volunteer, I will reply.
Yes.
The first option, surface resistivity, is definitely related to corrosion testing. Uh, Other tests are basically meant for parameters related to strength, modulus of elasticity, etc. So first option is correct.
Okay. Thank you. Thank you so much, Dr. Satish. Yes. So this is a very relatively easier question to attempt. The severity of corrosion rate of the embedded reinforcement can be qualitatively assessed. Yes, it is qualitatively assessed, and these are not fixed numbers because you're not directly taking samples from the concrete from the core of the concrete. Rather, you're just measuring it from the surface resistivity, and I'll also share some tips. Sorry, share some knowledge. Why is it a qualitative assessment and not a quantitative or a reliably quantitative assessment? Because surface resistivity of concrete tests, these tests are dependent on the moisture condition. Moisture condition of the concrete surface. So typically four electrodes. It is a equipment with four electrodes, which is placed over the concrete surface, and it essentially uh, so the current so, and the these electrodes, what they do is the current passes from one electrode to the another electrode, and there is a electric potential that is created within these two inner electrodes, and this is what is measured. This electric potential is measured, and the amount of current, that is the amount of charges that is able to pass through the concrete, through the surface of the concrete, that will give you an idea about the surface resistivity of concrete. So if the concrete is very dry, this test will not be reliable, and hence it is carried out mostly on the concrete, on wet concrete surfaces, or before carrying out this test, the concrete surfaces are provided with enough moisture so that it will probably give us with reliable results, and therefore it will only give us a qualitative idea of the kind of the conductivity or the resistivity of the concrete, and not a very quantitative idea because it is subjective to the moisture condition. Also, we are conducting this on over the surface, so it will give us an idea about the surface only and not the core of this concrete. But yes, it will surely give us an idea about the corrosion rate of the steel reinforcement. All these three tests, rebound number, it only gives us an idea about the hardness of the concrete surface, and not anything about the corrosion rate. Pulse velocity, it gives us an idea about the quality of concrete based on pore distribution. or volume, etc. Impact echo, again, it gives us an idea about the quality of concrete and not again the density of the concrete volume. This gives these are not these tests are not corrosion tests, not tests for assessment of corrosion. Rather, they give us an idea about the quality of concrete. Only surface resistivity tests give us an idea about the corrosion rate. All right. So this is the correct answer. Moving
I
on
have
with the
something to add.
yes, yes,
Just 1 minute. The same test is being used extensively by hydrogeologists
okay,
for geotechnical investigations relating to parameters relating to rock, etc. But
okay,
of
yes,
course, scale is larger.
right,
They
right,
will
right,
use many hundreds of meters, same type of electrodes. Here we are using smaller equipments,
right,
but
right, right.
principle is the same
Yes,
principle.
yeah, they might be measuring the resistivity to
They,
the transport of the
yes,
ions through the rocks.
yes,
Yeah, yeah. This is
and
a right.
they are able to assess the rock type.
Hmm. Okay, okay, good to know. Thank you, Dr. Satish. Yes, so this is I mean, this is a very generic idea of measuring the resistivity between two surfaces or between any sorry, over a surface of any material, rather over any material, because that will give us an idea about how what is the rate of the transport of the current, and if the charge can pass easily through the surface, then it will have a uh, it has a very less resistivity compared to something which has a high resistivity that will allow less charge to pass through it, hence the current will be low. And it is typically so for surface resistivity, it is believed that if the concrete has a surface resistivity of higher than greater than 100 kilo ohm centimeter, then it is believed to be a good quality concrete, which will have a good corrosion resistance as well. So this is the parameter that is generally used. All right, moving ahead to the last question. This was a question of matching the columns. The column A contains the different types of test or assessment methods that we use in the laboratory or on field. And the column B contains the various precautions or the various limitations or the applicability of these tests to different conditions on site or over concrete specimens. So I'll read out the column A. It was sorptivity test, Werner 4-probe resistivity test. It is the same surface resistivity test that we just discussed. Rapid chloride penetration test, oxygen permeability index test, rapid migration test, chloride migration test, and silver nitrate test. And the column B contains the different conditions. Sensitive, which of these tests is sensitive to the coatings on concrete surface, capillary suction, chloride front, sensitive to the applied external pressure exerted by the water during the test, sensitive to high performance concrete, not applicable for concrete with corrosion inhibitors, not applicable for on-site testing, sensitive to saturation level of the concrete. Can somebody answer to this question? Yes, Dr. Satish, go ahead.
Uh, First one is related to uh, second item, capillary suction in column B.
Okay,
Capillary suction has
sorptivity
that
test.
correlation with it. Then resistivity test we have just discussed, that is sensitive to coatings on the surface. If if there are coatings on the surface, results will be misleading.
Right.
Then rapid chloride penetration test. Uh, in case you are using inhibitors in concrete, then it cannot give meaningful results. So it's not. Yes, oxygen permeability index test cannot give good information in case of high performance concrete.
Right.
Rapid migration test, that is basically a test in for the laboratory, not for site. And silver nitrate test a direct correlation with chloride front, as you mentioned in one of the replies earlier.
Right. Yes. So yes, thank you, Dr. Satish. This
Yeah.
is the different. These are the different answers to the question. So I'll just, yeah. This is the options that are given. The second option was correct. So the column A matches, the number A matches with the 2, which is the sorptivity test, is related to capillary suction. The capillary pores present within the concrete, they tend to, due to the capillary stress between the small sized pores, they tend to suck the water from outside into inside the concrete. And this is the sorptivity test that is done to see the amount of water absorption. So basically, the concrete specimens are placed with the surface in contact with the water, and uh, the weight of these concrete specimens are taken before and after the tests, and it is and the amount of water that has ingressed inside the concrete or sorbed into the concrete, that is measured. So basically, since we know the area of these specimens, we can measure, the cross sectional area of the specimen is known, so therefore we can measure the depth of ingress of the water. So for sorptivity tests, if the results give sorptivity, the ingress of less than 7 mm per hour, so every hour sorry, this is a root over of the, so every it is, these are carried out in regular intervals, and if the sorptivity test gives results of less than 6 mm per the square root of r, then it is believed to be a good concrete, right? The Van floor probe resistivity test, since it is a surface resistivity test, so it is sensitive to the coatings on the surface. So sorry, yes, so it is sensitive to the coatings on the surface. So before carrying out this surface resistivity test, we have to ensure that the concrete surface is smooth and it is free from any kind of coating or paints or the plaster that is provided, that is applied on the concrete surfaces for finishing. So it has to be removed before carrying out this surface resistivity test, because these materials would influence the results and will not get a complete idea of the uh, quality of the actual concrete, rather will get an idea of the coatings or the plaster that is present over the concrete. So this is sensitive to the coatings on the concrete surface. The third is the rapid chloride penetration test, and it is not applicable to concrete with corrosion inhibitors, as Dr. Satish also mentioned. The presence of corrosion inhibitors can interfere with the chloride penetration or the ingress of chlorides, and it restricts the ingress of chlorides, and therefore using this test will not get an idea, a complete or a quantifiable idea about the chloride penetration when the concrete is dosed with corrosion inhibitors. So this is not applicable for concrete with corrosion inhibitors. The oxygen permeability index test. So basically this is another test in which the test setup uh, seals the concrete specimen and allows only the movement of the oxygen that is provided externally under a pressurized environment to flow through the concrete, inside the concrete, and the pressure gauge present in the test setup, that they measure the drop in the pressure inside the pressurized container of oxygen cylinder, and based on that drop in the pressure, it is believed that the oxygen, since the environment is totally sealed, it is believed that the oxygen has penetrated inside the concrete, and based on that we determine the oxygen permeability index. So this is sensitive to high performance concrete, as in it should not be done on high performance concrete, because generally the for OPI index OPI tests, oxygen permeability index tests, we believe that a OPI value of greater than 10 is an indicator that the concrete is of good quality. And in the case of ultra high performance concrete, since we use we tailor the mix design such that it has a very high packing density and it has a very low permeability. So therefore the OPI values that are obtained when this test is conducted over high performance concrete specimens, the OPA values are generally over 10. So you will not get an idea about the quality of concrete based on the OPA test when it is the concrete is of high performance type. So this is sensitive to high performance concrete. Rapid migration test, as already Dr. Satish has mentioned, this is not applicable for on-site testing. So and the silver nitrate test, as we have also discussed previously, this is used to determine the chloride front. So these are the answers I have already mentioned. You can check it out. So that completes the number of all the questions that were given to you in the assignment 4. And so thank you all. If you have any questions, the session is going on till 8 p.m. So if you have questions regarding the lecture or regarding these assignment questions that we solved right now, you can raise your hands and ask your questions. Otherwise, the session is done for today. It will be, I'll be present in this in the meeting till 8 p.m. So you can raise your hands and ask your questions.
Well presented.
Thank you, Dr. Satish.
Sir, will you be discussing the assignment 6 questions next week?
Yes, probably. I guess this is assignment 4.
5.
So
Yeah, 4.
this is assignment 4, so we'll be discussing the assignment 5 questions next week. I get so what I do is generally after you submit the assignment answers, then only we'll be able to discuss the assignment questions. So before you submit, before the deadline, we can't discuss the assignment questions. So
Okay, sir.
this is only to help you learn the subject better and to develop a good understanding of the of how to answer these questions and what these questions are related to, and not to help you get good marks in the assignments. So
Yes, sir. Yes,
yeah.
sir.
If you have certain doubts, then you can of course ask, but I won't be able to help you with the assignment questions directly which you have not submitted or the deadline hasn't passed already. I won't be able to give you the answers to those questions.
Okay, sir. No problem.
Yeah. All right, we're closing the session for today. We'll meet again next week on Saturday from 6 to 8 p.m. Thank you.